I manage a project called the Advanced Air Transport Technology Project within NASA Aeronautics, and we're the project that supports subsonic transport research for NASA. So the first technology I'm going to touch on is called the transonic truss-braced wing. This is a technology that we've been working on in partnership with Boeing for the last few years that allows for much longer, more slender wings, reduced fuel burn, and reduced CO2 potential on the order of 5 to 10%. And the key technology is, as the name implies, by bracing the wing with a truss or a strut to allow for those long, slender wings to be practical and durable within the aircraft. The second technology I will touch on is compact gas turbine engines, or small core. This is where we think there's a carrot on the order, again, of 5 to 10% if we can improve the thermal efficiency of engines through increasing the overall pressure ratio. So we've been working over the past few years with a couple of our partners, including Pratt & Whitney and General Electric, on the rear stages of the compressor, where the leakage flow over those very small blades becomes a problem. So we're looking at ways to offset those reductions in efficiency and allow for those high pressure ratio engines, and thereby increase the thermal efficiency of the engine. Again, estimates indicate maybe a 5 to 10% fuel burn benefit depending on how it's employed. There's also a secondary benefit for the small core in that by reducing the size of the core, we can facilitate a higher bypass ratio engine. So we've also been working with partners on low pressure ratio fan technology. The combination of the low pressure ratio fans, the high bypass ratio, and the efficient core can facilitate upwards of a 15% fuel burn and CO2 reduction for future aircraft. The third area I'm going to talk about is somewhat newer relative to the other technologies, and that's electrified aircraft propulsion. And here we're talking about electrified propulsion for larger aircraft, single aisle and up, where it requires megawatt class components and powertrains to really get an effective improvement to the current architectures. And also there's a secondary benefit to this technology, is that you could facilitate the use of other energy sources by charging batteries. So not only is there a potential fuel burn benefit, but also a potential CO2 benefit beyond that for electrified aircraft in the future. So really excited about that. And then finally, I want to talk about boundary layer ingestion. This is a technology that we've known about for a while. We had a really successful experiment with United Technologies Research Center a few years ago to look at the ability to achieve high fan efficiency with a boundary layer feeding into that fan. The boundary layer ingestion has a nice coupling with electrified aircraft propulsion. For example, the StarCable concept that NASA has been developing employs an electrified powertrain which provides electrical power to that rear fan at the tail of the aircraft. And then by ingesting the boundary layer from the fuselage, we think you could achieve a 5 to 10% benefit in fuel burn and CO2 relative to traditional aircraft. So those are just a few of the areas that NASA is working on with our partners to benefit the community, benefit the environment through reductions in CO2, through a number of technologies that we think have great promise. Thanks. Hope you have a great rest of the meeting.